Hello, everyone. Welcome back to SAT Math Question of the Day. We have with the Brothers Chaiken basically fall over ourselves trying to help you trying to offer approaches to both studying for the Math SAT and also doing Math SAT questions. We have Seth Chaiken, Professor Emeritus at SUNY Albany, University of New York in Albany, with a PhD in Math from MIT. And Joel, I have a mechanical engineer trained as a mechanical engineer, PhD in mechanical engineering from Columbia University. So, in terms of approaching studying for the Math SAT, Google Khan Academy SAT Practice. Yeah. You will see two courses, one course for the non-digital SAT, one course for the digital SAT, depending on which SAT you plan to take. We are going through the advanced questions. These are great because they tell you exactly what is on the SAT. They partner with the SAT people. We go through all the questions on the advanced level with the idea that if we offer approaches to the advanced questions, you can do the mediums and the foundations yourself. So today we are in the advanced section, and I think yesterday we did quadratic equations, solving quadratic equations. Today we do linear and quadratic systems. So let's practice. Let's do a let's go. We'll do the first question. We plan to cycle through all these advanced questions. It'll take us many weeks, to say the least. Okay, please everyone read the question. Ooh, look at this. We don't have to show. We have to make the thing smaller, don't we? Ooh, okay. Please read the question and come. Well, I guess we can just go like that, right? And now everyone will see it. Okay, everyone, please read the question, pause it, come back, and we'll do it. Okay, the parabola shown is defined by this equation. If the line defined by that equation is also graphed, at what point do the line and the parabola intersect? I guess if you're really neat. Now, those points are they very far apart from each other? I mean, no, they are. They're all pretty far apart from each other, aren't they? So you could probably just graph this thing. Right? You could go up to 9. You go up to 9. Hold on. So, there's these different modalities. You could solve a problem algebraically with a table or by graphing. If you go up to 9, we'll try to graph this thing. And, oh, no, it's not 9. It's 9 minus 40 thirds. Right? Which is 40 thirds is about, it's about 13, right? So it's 9 minus 13, so that's negative 4. Negative 4 is the y-intercept.
This is approximate.
Yeah, approximate. Negative 4 is the y-intercept. Now it's negative. Now the slope is negative. Negative 8 thirds. So we go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. So it goes sort of like that. Right? So, is there an answer that's sort of near there? Near there? Let's see. Oops. Ooh, that's not good. Oh, you have to go like this now. Ah, there we go. 0. Wait, hold on. It's negative 4. There, negative 4. Ah, 0, negative 4 may be the answer. 4, no. 3, negative 7, no. And then negative 1. Oh, maybe negative 1. Negative 1, negative 5 thirds? Negative 5, negative... I don't know. But maybe we can try. We could try 0, negative 4, can't we? We only have to try it in here. 0, negative 4. If that's 0... No, 0, negative 4 doesn't work. No. But it's close, right? Because if that's a 0.
Okay.
Negative 4 doesn't work. So maybe it's negative 1, negative 5 thirds. Yeah. That would seem to be the one that would... Negative 1.
Okay. Well, I think what I did was they give you the graph.
Right.
So what I did was check which of these points. So my approach is 1, check which answers lie on the parabola.
No, well, no, you mean lie on the line. We know
and then, of those that lie on the parabola, check whether they satisfy of those.
Right.
Check if they satisfy the linear equation.
Right.
So you go through each one.
That takes a lot of time.
Oh, God. 0 minus 4. Actually, 0 minus 4 does fit on the parabola, but what you calculated is that it's not on the line.
Actually, yeah.
4 minus 20 over 3 it's negative. It's about a little more than 7. So this probably lies on the parabola. So let's see if it lies on the line. 5. Let's see. X is 4. 4 plus 5 is 9. Multiply that by 8/3.
Seth, you're taking a lot of time.
Well,
just no, it's more Seth.
Could you do it faster?
Well, no, let's check this one.
Okay, I'll calculate it out, and you try to figure out the answer. We'll see which one comes up first.
Fine, I'm going to do the one.
I'll be silent. You be silent.
Fine. Okay, here we go. Yeah. I got it.
Okay. How'd you get it so fast?
I'll tell you how I did it so fast. I graphed the line. I graphed the linear equation approximately. Okay, I graphed it approximately. I figured out what the y-intercept was, and I drew this silly little line approximately. No, but the first thing I did was I looked at the answers and said, "Are there any answers? Are all the answers sort of really far apart from each other?" And the answers really are. All these points really are very far apart from each other. So just approximating the stupid graph will get us in the right direction. And first of all, so this is a possible answer, but this is easy to check, right? It doesn't work here because we know the y-intercept is this, actually on the line. So the only one that makes any sense is the -1. It's not a great approximation. It doesn't really look like it fits, but this is the only one that makes any sense. I tried this in the equation, and voila, look at this. It's -32 fifths plus 27 fifths, which is negative 2/3 plus 27 thirds, which is -5 thirds, and it's the answer. So I combined both the graphical modality and the algebraic modality to get the answer as fast as possible.
Very good.
With the understanding that the solution to they even tell you at what point do they intersect, as opposed to what's the solution to the set of equations. Therefore, you have to know that means they intersect. Yeah, they even tell you explicitly, we need to find the intersection. So you just graph the things. But thanks to Seth for reminding me that all I had to do was really just check the answer here. I would have realized that 5 or 10 seconds after if you didn't remind me, but thanks for that.
Yeah.
Yeah.
Well, here's another. Okay, for checking the answer, maybe the arithmetic would be easier if you converted that linear equation to an equivalent form by multiplying both sides by 3 to get 3y.
3y.
equals minus 8 times x plus 5.
That's true.
Plus 3 times 9 is 27.
Right.
And then you could simplify this to 3y equals, well, minus 8 times 5 is minus 40.
Right.
So you have minus 8x minus 40 plus 27.
Right.
And minus 40 plus 27 is what, 13? Is it?
Yeah, right, yeah.
And so you could check, plug in for the x's. It's easier. So the equation is equivalent to 3y equals 8 minus 8x minus 13.
Minus 13, right, yeah.
Okay, and then you could figure out with whether we plug in minus 7, plug in minus 1. So let's check the D question. Minus 8 times minus 1 minus 13 is 8 plus minus 13 is 5.
Right.
Right? And the y,
yeah.
Right?
Yeah, positive.
But to plug in the y,
no,
and
it's
you get
minus
3.
It's minus 5. It's minus 5 because it's 8 minus 13. It's 8 minus 13, so it's minus 5.
Yeah, okay. But if you plug in...
Yeah, so y...
They plug in y equals 5/3.
Right.
3 times a minus 5/3.
Right.
Right?
Right.
Equals minus 5.
Yeah.
Yeah.
So it looks like...
But, the troublesome part of this this problem is the arithmetic with depending on how you do it. Depending on how you do it, you'll have to deal with more or fewer thirds. You have to deal with thirds because the y value they give you here, the 2 of the y values are fractions of thirds. Your fractions with the denominator of 3.
Right.
So so this is this relies upon care in doing the arithmetic.
Yeah, but
also, so there's the concept of how to do it, and then the care in keeping your wits about you to do the arithmetic.
Yeah, I mean, I don't know whether you really have to simplify. If you do it the way I...
You don't really have to. You do this equivalent things with thirds running around. Same thing.
No, but all I'm saying is that if you narrow down the answers to these two, you don't have to do all this algebra stuff. You just plug -1 into this thing and be careful. Be careful. You have to be careful.
Yeah.
What was I going to say? Oh, yeah, so the full-blown algebraic approach is to set the two y's equal. You get this nasty quadratic, and you have to solve it. That would be the question: is at how many points do they intersect? But let's also make a really important point. You are given an online calculator on the digital SAT, and I believe it's a Desmos calculator. And I think you can graph 2 equations on a Desmos calculator. Practice on Desmos, please. But you do this blue book thing, they'll give you the actual they'll simulate the test, and I think you can actually graph the 2 things, and then look and see exactly where they intersect. You can do this question completely on the computer, which is probably the best way to do it. We didn't do it that way, but I sort of did it that way. But I think that would be the way actually to do it in practice. So when you're studying for the SAT, download this Blue Book thing, and it simulates the actual test, and then you can practice using Desmos on Blue Book.
Do they give or do they tell you? They give a rating of how hard this question is?
No, I don't think so. And no, well, we know it's an advanced question, right? Because we're doing the advanced. We have 3 levels: foundations, medium, and advanced. So this would be the advanced level. So let's see how they do it. I'm interested to see if they doubt they do it full algebraically.
Well,
Well,
let's see.
full algebraically. Oh God, full algebraically, you would say this thing equals negative 8 thirds x plus 5 plus 9, and then you solve this quadratic equation. Forget it. There's virtually no chance they do that. But that would work, particularly if you wanted to know how many solutions there are. So let's see how they did it. So I think this is the answer. It's so important to think in different modalities, and please try to be familiar with the graphical modality. I'm interested. They should also suggest that, hey, you could do this whole thing with just a Desmos.
Yeah.
Wow, that's nice. Unfortunately, when they show the calculator, they don't show a graphing calculator, which is not realistic. Download Blue Book and see exactly what they give you. Aha. Solutions are points where the two equations intersect. Okay, first graph the linear equation. So they are suggesting using graphing calculator. Open up a Desmos on the side then to help you. Since linear equations are in points of form, we know one of the points on line is negative. What? First graph the linear equation. They
did what you
zeros
did.
and -5. See, they put x as -5 in there.
Aha.
That was very clever. That saves you time. That's smart.
Yeah.
That's smart. And then you graph the line. Then you go 8 thirds.
Aha.
Then you graph the line. Then you give you an approximate answer.
Oh,
Notice
wow.
the
The
same.
line is apparently tangent.
Notice that they said exactly what I did. They offer two possible solutions. So you check them, right? Substitute these points into the systems. You only have to substitute it into the
very good.
into the line, really, because they graph the. You can see that 0, -4 is on the parabola, so you don't really have to check. Oh, so you don't really have to check 0, -4 on the parabola. I mean, you could do that by eye. That's really easy. And that one doesn't work. So this one's the only one that works. So if one works, you don't really have to check the other in practice.
Well, what about 0 -4? Go down for the
Yeah.
point. Scroll down.
Yeah.
What works? Oh, but the it works for the linear, but not for the quadratic.
No, 0, -4 works for the quadratic, not for the linear.
Oh, okay.
Yeah,
So
it
it
works for the
fails for the linear. Yeah.
Yeah.
Okay.
Yeah. Okay.
Yeah.
So they did the graphical approach. They did
Yeah.
the two
Yeah,
modalities.
they
did
did.
exactly. Yeah, that's the fastest way to do it.
Yeah,
If you're not
good.
sure about the fundamentals about what we just did, go back to the. They have a thing. They have a option to learn the lesson, learn the whole unit at Con, and you can go back and read the unit, read the concepts behind the unit, and make cheat sheets to when you're studying. I strongly suggest make cheat sheets. Good approach.
Unfortunately, they don't allow you to use rulers.
Seth, what do you mean they don't? They give you a graphing calculator.
I know, but if it were on paper, you could do the graphing by using a ruler.
You can use the side of it. You can use a ruler, maybe. You can.
Yeah, but they don't. They want the rule. The rule is no rule. There's a rule against rulers.
Right, but if necessary. But on the linear, but if this question may be on the calculator. Well, if this is not a question on the linear on the non-digital side, but if you're really in trouble on the non-digital side, and you can't wait, but you could bring a graphing calculator to the non-digital side. Yeah, you can bring the TI-84 calculator non-digital side, and then you can graph two lines. So you have to, if you're not taking the digital thing and I'm taking the digital SAT, be sure to know how to use your TI-84 graphing calculator. So,
does the TI-84 simply solve problems like this?
Well, it'll graph two equations.
Well, could you ask it to so you could input two equations, but then could you ask them to solve the two equations together?
I'm not sure. You can certainly program it that, but you may not be allowed to use the programming side of the TI-84. but you can go through it. You can look at where the points intersect, and you can see, and
Yeah.
you can zoom in and zoom out.
Well, their method of graphing was very, very good. Very good idea.
Yeah,
You evaluate,
let's learn from that.
find one point
Yeah.
that's easy to find,
Right. Yeah. Yeah.
and then
Mm.
use, and then read off and then plot the other point so that it has the slope and it's an integer point by going down 8 and over 3.
Yeah. We need to learn
Yeah.
from that. Very
Yeah.
important. Learn from the subtle points. They will save you time. This could save
Yeah.
you. This can save you easily 10, 20 seconds.
Yeah.
That was very smart.
Yeah.
This also has a little bit to do with that translation stuff we talked about. If you make x is -5, this becomes 0, and then x and y is 9. Yeah, so we can do that. -5, 9, and then you go 1, 2, 3, 4, 5, 6, 7, 8, 3, and then you go like that, and then they'll notice they purposely gave you 2 possible points, right? -1. They purposely did that way, so you have to check.
Mm-hmm.
Very smart way of doing it. We have to remember that. We have to remember.
Very good.
Okay, learn from everyone and everything. So we will also show on Desmos how to actually do it, because on the digital side you will be given a Desmos calculator. So let's go to Desmos here, and let's type the equations in. Y is equal to, let's take some time to do, 1/3 x squared minus 2x minus 4. That looks good. And let's do y is equal to, I'll just do this, -8/3. I love parentheses. That looks good. X plus 5 minus 9. So there's a mistake there. There's a mistake there. -8. So what's the mistake? What's the mistake? -8/3 x plus 5 plus 9. So
it's a +9, not a -9.
Oh, it's a +9. Got it.
Yeah.
Okay, so then that's good. Okay, there we go. So this
Bingo.
is what happens if you get Desmos. So you have this point. Well, that's the answer. Notice here that it's 0, -4.333. Oh, that's the. Oh, I see what those dots are. That's the x and y intercepts. See, those are the x and y intercepts.
Okay.
So that's that, but they are showing a point of intersection, which is -1, negative that, which is -5/3, and then you get the answer like that. I'm surprised the answer they didn't show you. Just how to do it on Desmos, because you will have Desmos on the phone.
Yeah. Please expand. Click on the plus to make it bigger so we can see.
Yes.
The nature of those.
I expanded it, but where are the dots? How come we don't see the dots after I expanded it? Why don't the dot? There we are. Okay, here we go. Ready?
So now expand it. There we go. Yeah.
Oh, look at this. We can go like that.
Yeah.
Oh, we lost the dots.
Well, click on the window with the curves.
There we go. There we go.
There you go.
Dots,
yeah.
Now I don't know what you're going to be getting on exactly.
Yeah.
What you're going to be getting.
Yeah, just click on where they intersect.
Doesn't show. Yeah.
Yeah, click in the air where they. There you go. There you go. So that thing that you're pointing to now is where they actually intersect.
Right. That's right.
And notice the other 2 gray dots.
Yeah. Right. Yeah.
Are not on the green curve. So they are.
This one certainly
just the axis intercepts of the straight line.
Right. Yeah. So you have to be. Yeah.
So with Desmos, A question like this, Desmos is the like one of the fastest ways of getting the answer.
Yeah, I mean, it does take a little time to actually. Well, it does take a little time to actually type those in. You got a lot of parentheses in there. And by the way, I
Yeah,
made a mistake. I did the -9, the +9.
yeah. Well,
I
when you use it on the when you're taking the exam, would you have Desmos and the questions in separate windows?
I think so. Yeah, everyone, you need to go to Blue Book, download this, follow the instructions on the digital SAT. You download this application called Blue Book. Then you take a test that simulates exactly what you're going to see. And I think yes, I think it opens up a separate little screen, little thing, and you get to
Yeah,
move the
yeah,
graphing calculator around. I'm pretty sure you
mm,
can graph 2 lines on
yeah.
the Blue Book. But please, everyone, go to Blue Book and download it. And by the way, Blue Book right now only works on a Microsoft computer as of now, August 8th, 2023. So if you have an Apple, you got to get yourself, you got to borrow a Microsoft computer to download Blue Book.
Huh.
Yeah, I know. Well, hopefully, I can't believe it. So many people have Apples. It's just so strange that they don't have that right now.
Well, could you get a virtual machine and put Windows on it
Yeah, I guess you
on
could.
your
Right?
Apple?
Yeah. Right.
Ah,
Yeah. Right. Yeah. Okay, so this completes this part. I don't know if you realize this. We added this in after we made the original video. So anyway, now of course the end of the video will start with our boilerplate that's at the end. So I guess that's it, right?
yeah,
Yeah,
yeah.
okay, everyone, please like us, dislike us, give us comments on our YouTube videos. We need the comments to get feedback. If you have any SAT math questions, please email them to us at satmathquestionoftheday@gmail.com. And have a nice day, and we hope to see you tomorrow. Bye-bye. Seth, want to say goodbye?
Bye.